Hey guys! Remember the ripped out original engine mount of the Opterra? Well, we fixed it and it's now functioning as a support and cover for the new engine mount, reducing turbulences. And also we cleaned up the cabin, making it more flight ready, coming from this cable mess to something a little bit more organized, that things are staying in place and not moving. How we did it and how we went there, let's talk about after the intro. Let's roll it! Hey guys, and welcome back to the channel. Thank you for joining part 6 of the Parrot Disco /Opterra hyper long range drone build. Over the last days I really had some improvements, cleaning up the cable mess inside and getting it ready for flight, at least much closer to a first flight. Also we did fix the ripped out engine mount at the tail, and really thanks to R2D2. Droid help is free in my part of the galaxy. Well, I guess it depends on what part of the galaxy you're coming from. What looks like primer here is just some flat gray paint, and we are preparing the fuselage with that for the camouflage pattern we are planning. There are limitations what we can really do to styrofoam on the surface, and we cannot really improve the flight characteristics. If we would have carbon fiber, we can really do something and work with the aircraft and improve the surface itself, but here it's more like a cosmetic kind of thing, giving it a camouflage paint job. Also, we don't want to overdo it, we don't want to overwork the paint. Paint is heavy and we don't want to have more weight than necessary. Also, since we don't have any flight characteristics improvements or any other benefits like protection from it, we just try to keep it to a minimum. This square here is the cutout for the altitude meter from the Parrot Disco flight control unit sitting in the Opterra frame now. When fixing the original engine mount back onto the fuselage, I used some carbon fiber reinforcements that it's not falling off and right into the propeller blades when it's in flight. Right now, cosmetically not very pleasing, but it will get a paint job on the underside as well, and with that it's fading away. I was testing some spray paint and the yellow one here is eating in. The orange one is perfectly fine. It's actually from the same company and the can looks the same. There is no real way of 100% knowing which spray paint is fine for styrofoam and which one is not. Therefore, it's really crucial that you are testing the spray paint you're using on your model, not destroying it. I was testing all shades of gray I'm using for my camouflage pattern, and most of them are fine. But sometimes a can is sneaking in which is not, and therefore it's really important that testing is always done before using it on the actual model. Now we are losing the last decals and the stripes of the Opterra, making it more like an own new aircraft. We don't need to overwork the styrofoam structure of the aircraft before painting it, but sanding it a bit down, making the paint stick a bit better, and that it's not cracking and peeling off as easily, kind of helps to give it overall a better look. Here now the new internal design of the fuselage with a new build frame, that the batteries and everything is fixed and holding in place, that when the aircraft rolls or is doing power loops, nothing falls out and nothing moves. All this will have to go into the fuselage. In the nose of the fuselage, being the lens housing, everything is blacked out with flat black paint so that we can reduce possible reflections on the lens to a minimum. The entire powertrain is new, and this year's the Sunny Sky engine we are using with the final propeller blades and the propeller carbon fiber 11x6, and that Sunny Sky engine and the propeller is hanging on the new engine mount we just built. That wiring harness on all the cables, connecting the Chuck with the flight controller and the servos and routing it back to the batteries, all that will be tucked away in the fuselage and tied down so that we don't have any trouble with interferences when the aircraft is in flight. It was a bit challenging to accommodate the clover antennas of the flight controller from the Chuck, so they're tucked into the right and left of the Chuck itself, and they're just fitting in there. Likely they do not have the best reception, but since we are planning to fly over 4G mainly, well, we don't really need a very great range of those clover antennas anymore. This is the new wooden frame we were building, and that is holding everything really snugly tight in place in the fuselage. It's holding in place with just 4 screws, and it can be completely deassembled if needed. The frame is holding in place by being tucked under the walls of the fuselage and cannot move. biggest advantage of a larger aircraft is that we have a way more payload. So we can have two 5000 mAh batteries in this fuselage. Accommodating that much 3S battery power gives the aircraft a really long range. And that is the motivation what we want to do here. We want to fly over 4G and we want to have a very long range, and we don't want to limit ourselves by batteries. Another great characteristics of this aircraft is that it's a flying wing, and the center of gravity is really set way back. So we have the ability to balance out the aircraft only by moving the batteries, since they are sitting mostly in front of the center of gravity. We don't need to waste any payload by balance weights. We can lose them completely, and we can balance the aircraft perfectly fine with all components on board we actually need for flight. Here we have the connectors for the engine, and the red and black cable are flipped in this case, since we reverse the engine because the engine in this scenario is pushing now. The new engine mount is designed in a way that it can accommodate the cables and route them through the middle of the new engine mount back into the cabin of the aircraft. The nose of the plane is basically complete, and we can screw back on the front cover glass, and the mount for that we were building in an earlier episode of this Opterra Parrot Disco long-range drone build. Rebuilding the front of the aircraft and rebuilding the nose cone is in part 2 in the playlist, and you can find it there. And now finally we can throw the propeller blades on. They're carbon fiber 11x6 propeller blades, and we will use exactly that propeller for the first flight. Before the first flight can really happen, one crucial part is missing, and that is the propeller blade stopper. When the propeller blades are falling to one side and then the engine kicks in, it can really cause vibrations to rip out the whole engine mount, which is now fixed, but the vibrations will cause damage to the fuselage and can potentially crash the whole aircraft. The plan is to fly with only one battery pack during the first flights, holding that one in place with the battery straps from drones I'm reusing here. And the one battery is heavy enough already that we can balance the entire aircraft out. We don't need a second battery to have enough balanced weights. So for that part we are fine. And this here is why we need a propeller stopper. It is a little bit of an unwanted simulation what is happening when the propeller blades are falling to one side and then we are throttling up. But it happened just for a brief second and I killed it immediately. I have the arm switch right on my left finger, so that was fine. However, it is clearly visible that even just throttling up a little bit, vibrations were significant, and by throttling up more when in flight, that vibration would be substantial, potentially crashing the entire aircraft. Now when we are really balancing carefully the propeller out before throttling up, everything is perfectly fine, and that job is doing the propeller stopper from now for us. I'm having it on order for quite some time, but when it is really coming in and when I can throw it on the propeller, well, we will see, hopefully soon. So we can see once the engine runs, it really runs very fine. So it is great that at this point we already can ensure that this is really happening. Even with the carbon propeller blades, everything is okay, there are no issues. The only thing besides the propeller stopper, I have to measure the amp actually drawn by the new powertrain and by the new engine in combination with the propeller, because I do not want to overstress the Chuck flight control unit, that there are later overheating issues during flight. Therefore I want to stay close with the amps drawn by the new powertrain to the original powertrain of the Parrot Disco. Therefore around 5 amps above the original drawn amp by the original setup, landing then by around 20-ish amps might be a viable option. We will see where the current setup is landing when we are testing it. So here we are. Another big step in the right direction to get that thing up in the air. When the missing parts are coming in, not sure yet, but I will keep you posted. I hope that will be soon, before the year ends. We will see. So far, as always, thanks guys for watching. Have a great rest of the day. Like, subscribe, and see you in the next one.